There are minds that are ahead of history and unravel the deepest mysteries of the universe, and among them stands out the figure of Peter Higgs, a visionary whose name is intrinsically linked to the discovery of the cement that supports the most fundamental structures of the cosmos. Today we are going to know some fundamental facts of the boson of Higgs that few know, and that is very important for the understanding of the universe. Peter Higgs anticipated the existence of an elusive particle, the boson that would bear his name long before science could test. His career culminated at an epic moment on July 4, 2012, when at the age of 83, he witnessed the ovation of his colleagues in CERN. After decades of waiting, when the existence of the predicted particle was verified in an interview, he shared his astonishment and emotion, revealing that his doubt did not live in the validity of his theory, but in himself if he would live enough to see it confirmed. This is the story of a man whose faith in science and perseverance challenged the barriers of time, and whose legacy lasts in the very pages of human knowledge. The world of science is mourning for the loss of one of its giants, the British physicist Peter Higgs, affectionately known as the father of the boson of Higgs. Peter Higgs, born in Newcastle-upon-Tyne in 1929, died at the age of 94 in his home in Edinburgh, leaving an indelible legacy in the history of physics. Higgs' childhood was marked by numerous residence changes due to his father's work and health problems. His interest in physics woke up early, influenced by Paul Dirac's work, father of modern quantum mechanics. His educational career, from his training in Bristol to his university studies in London, raided the way for a brilliant career in the field of theoretical physics. After a brilliant academic training in mathematics and physics, Higgs became a professor of theoretical physics at the University of Edinburgh in the 1960s. It was during that time when he believed that the particles did not have more at the beginning of the universe. This is because the extremely hot and dense conditions of the primary universe, the Higgs field, was in a state of high energy, which means that the particles weighed weakly with it, and therefore did not acquire mass. However, as the universe cooled and expanded, the Higgs field experienced a phase transition, similar to the solidification of water on ice. In this new state, the Higgs field acquired a lower energy value, which allowed the particles to interact more strongly with it. This interaction with the Higgs field is what provides the most elementary particles. According to this theory, it was the answer to why all particles had mass now and where that mass came from. This is perfectly compatible with the Big Bang theory. The revolutionary idea is that subatomic particles should obtain their mass through interaction with a theoretical field, the so-called Higgs field. The interest of Higgs in the enigma of the mass of the particles led him to propose in 1960 for a revolutionary mechanism: the existence of a field that permeated the entire space and gave the particles more. This field, known as the Higgs field, would explain why some particles have mass while others do not. Some thought this could be the famous ether, and has nothing to do. Before 1964, the Standard Model of Physics had an important lagoon. I could not explain why the particles had mass. It was in that year when Peter Higgs, along with a Belgian team led by François Englert and Robert Frout, presented independently a revolutionary theory that filled that void. To understand what the boson of Higgs is, we first need to understand the concept of mass. Mass is the property of matter that expresses its resistance to movement change. Although mass and weight are related, they are different concepts. The mass is defined in terms of the resistance to the change of movement of a body, while the weight depends on the severity of the place where the body is located. Imagine an invisible field called Higgs field that permeates the entire universe. This field is crucial because the particles only acquire more when interacting with it. It is as if that invisible field was the glue that gives the substance to the particles, from the electrons to the quarks, allowing them to have mass, and consequently form everything we see around us. It is as if we were immersed in a quantum ocean that allows us to have mass thanks to the interactions. Without the Higgs field, we would integrate and the universe would lose its balance. In other words, the Higgs field is what unites the universe. Even the boson of Higgs, the particle that bears his name, arises from the excitation of that invisible field. It is as if it were a wave in an invisible ocean that is the Higgs field. Our universe is defined as an ocean of waves in interaction with other particles, and each particle interacts in a certain way with the Higgs field. However, there are particles that do not interact with Higgs, such as photons and gluons among others. The discovery of this mechanism for both Higgs and Englert and Brout was a crucial mile of the cosmos, but it was necessary to find the boson of Higgs in the experiments. For decades, scientists around the world tirelessly sought the Higgs boson, considering it the most coveted particle of modern physics. Many began to think that the Higgs boson did not exist. Peter Higgs had to endure initial skepticism and the rejection of some scientific magazines, but Higgs persevered, and his work finally found recognition when technology made it possible. This particle, popularly nicknamed as the particle of God, was finally discovered in 2012 in CERN, in the Great Hadron Collider, commonly called the Big Bang Machine. Buried 100 meters deep underground, in a 17 tunnel of circumference, surrounded by superconductor magnets that have structures that drive particle energy traveling to almost the speed of light. When these particles collide, they release a huge amount of energy. This energy is so large that you can create new particles for a brief moment. It is as if you hit two rocks together and see sparks to fly. In the case of the Great Hadron Collider, these sparks are subatomic particles, some of which are very rare and difficult to find in normal conditions. In the context of the Higgs boson, the Great Hadron Collider was used to excite the quantum vacuum, which is like the Higgs field mentioned above. When exciting this field, scientists can detect Higgs boson and study their behavior. It's like looking for a needle in a hay. The discovery of the Higgs boson was made by collisions of particles at high speeds in the CERN. ATLAS and CMS experiments confirmed the existence of a particle with the characteristics predicted by Higgs boson theory. The international recognition of the scientific community was immense. This finding was compared in importance with the discovery of DNA, highlighting the significant impact that modern physics had in our understanding of the cosmos, and has given way to a new understanding of the universe in subatomic scale. Imagine that the universe is like a huge puzzle and elementary particles are the pieces of that puzzle. The boson of Higgs is like the tail that hits those pieces together, keeping everything together and allows the matter to exist. Without the Higgs boson, the particles would be everywhere and the universe would not have the structure we see. In summary, Higgs boson is like the invisible glue that keeps everything together in the universe. The boson of Higgs, as Peter Higgs described it, acts as the cement that joins the subatomic particles, providing them with mass and allowing the formation of matter. Although God's name caused controversy among some scientists, it contributed greatly to the fame of discovery. The physicist Leon Lederman and the scientific disseminator Dick Teresi published in 1993 the Book of the Divine Particle. If the universe is the answer, what is the question? Peter Higgs, although he was not religious, defended the compatibility between science and faith. Peter Higgs said that sometimes science and religion of confusing ways are mixed. Some people interpret scientific discoveries such as the boson de Higgs in CERN as evidence of the existence of God. However, this can lead to confusing thought. It is really intelligent to believe in the history of creation in 7 days. The nickname the particle of God for Higgs, although popular by Lead Lederman, was not originally conceived for that purpose. It is important to understand that science and religion are different areas and should not be confused with each other. His research career was closely linked to the University of Edinburgh, where he spent most of his academic life, being remembered as a great teacher and a person of great human quality. The discovery of the boson of Higgs catapulted Higgs to world fame, leading him to receive numerous awards, including the Nobel Prize in Physics in 2013, shared with the Belgian physicist François Englert. Higgs could barely contain the emotion and told reporters, "Sometimes it is good to be right." One of the great mysteries of the Higgs boson is that it is an ephemeral particle, is created and quickly destroyed. Although it has a specific mass, it lives very little time and does not have an electric charge or spin, an important property in quantum physics. However, there are still many mysteries to solve on the Higgs boson. It is unknown how to interact with yourself, and if it is an elementary particle, a mediator of interactions, or a compound particle. Resolving these mysteries could lead to new symmetries in particle physics and the prediction of new particles. To understand it better, imagine that the Higgs field is like water, and Higgs boson is like a wave that forms in that water. The wave, the boson of Higgs, is a manifestation of the existence of water, the Higgs field, and does not need to interact with something else to have mass. Peter Higgs had achieved a great achievement, but remained humble and modest until the end of his days, leaving a legacy that will continue to inspire future generations of scientists. A physics teacher who had the gift of explaining complex concepts in a simple but deep way. His theory of the Higgs field that gives mass to particles is essential for our understanding of the subject and energy of the universe, but beyond their scientific achievements. Higgs will be remembered as a gentleman, always generous in recognizing the work of others and encouraging future generations of scientists and academics. Peter Higgs has left us, another of the great scientists has left, and his theories opened a new door to the unknown. The ideas and some hypotheses then become theories and take a long time to be accepted. No scientific theory was accepted before without opposition. In scientific research, patience is a fundamental value, so we must continue investigating and proposing new methods to advance. There are still many unknowns to solve, so we continue working together and make something useful that deserves to be remembered. Maybe one day we give us account that we have contributed to the progress of humanity.